Welcome to Unit 1, Part 2, which is all about the units we're going to be using in this class. So, in physics, because it's a science, we use the SI unit system or the metric system. For most of our calculations, very, very rarely will we deviate from this. For mass, we're going to use the kilogram. For length, we're going to use meter. And for time, we're going to use seconds. Okay. Now, I hope that you have a good feeling for a meter. Remember, a meter is about a yard long. Not exactly, but close, so it gives you a feeling. The second is the time that you use every day. There's 60 seconds in a minute and 60 minutes in an hour. It's that second. Kilograms, on the other hand, is probably not something that you use a lot or think about a lot. Primarily because we don't work with mass so much in our everyday lives. We work with weights. If I go to the grocery store, I don't pay for my apples in kilograms primarily. I pay for them in pounds. It's a 3-pound bag, something like that. So what would you do if you went to the grocery store and your challenge was to pick one thing off the shelf that is about a kilogram? Would you know what to go grab? And to give you a good feeling for what that is, if you buy a liter of your favorite beverage, soda, water, whatever, that's going to have a mass of approximately a kilogram. So it gives you a feeling there. Why do we use the metric system? Well, we use the metric system because it's easier. So remember, in the English system, we have all these goofy conversions. We have 12 inches in a foot. We have 3 feet in a yard. We have 5,280 feet in 1 mile. These numbers have no relationship to each other. There's, the only way to work with them is by memorization, right? And if you need to go something bigger or something smaller, I mean, what do you use if it's the distance from the Earth to the sun? I mean, miles you could use, but it's going to be a really big number. Off the top of my head, the only number or only unit that is bigger than a mile that I can think of is the furlong. Now, how many of you have used furlongs in their everyday life? I'm guessing not many. What about smaller? What if it's something smaller than an inch? What if I wanted to specify something that is atomic scale in inches? It'd be a really, really small number. The English system does not adapt itself to really, really big or really, really small easily. On the other hand, in the SI system, all the conversions are factors of 10. So we have 10 millimeters is 1 centimeter. We have 1,000 millimeters is 1 meter. 100 centimeters in 1 meter. 100 meters in 1 kilometer. Oh, sorry, I said that wrong. 1,000 meters in 1 kilometer. Or we could go the other way. And it's all these factors of 10. And if I want to go bigger or smaller, all I got to do is switch my metric prefix. So it makes it very, very easy. Right? So what are the metric prefixes? Right. Okay, so here we have our metric prefixes. This is not a complete list by any stretch of the imagination, but it's a good start towards the metric prefixes. I'm going to ask you to memorize 3 of them so that you know them for an exam or a test, or if you have to take the MCAT or something like that. And those 3 are kilo, centa, and milli. It's not going to hurt you to know more of them, but those 3 will get you a long way. So you'll notice that in the middle here, there's no prefix, there's no symbol. That's because that's the base. So if these were meters, this line here would be 1 meter, and this would be centimeters and millimeters, or kilometers or megameters. Sounds weird to say it, but it's a true measurement. If we think about time, the line in the middle here would be 1 second. And then we could have kiloseconds or centiseconds and milliseconds. Not completely unreasonable. If we're thinking about mass, this line here would be 1 gram, and then kilogram is making use of this metric prefix, right? So when I go bigger, I go kilo, mega, giga, tera, and every time I add 3 zeros to my multiplication factor. So 1 kilometer means there's 1,000 meters in 1 kilometer. 1 megameter means there's 1,000,000 meters in 1 megameter, right? If I go the other way, if I go to centa, milli, micro, nano, what I'm doing is I'm adding zeros but making it smaller, so after the decimal place. And notice centa is an aberration in that it's a factor of 100 instead of a factor of 1,000. But it's used a lot, therefore we include it. There are other ones between meter or the base and centa or the base and kilo that just don't get used, so I didn't include them, right? So by 0.01, it means 1 centimeter is 0.01 meters. You're probably more familiar with that as there are 100 centimeters in 1 meter. 1 millimeter is 0.001 meters, or there are 1,000 millimeters in 1 meter. You can take it either way. Okay. So now, why do we use kilogram as our unit for mass in this class as opposed to the gram? And it really comes down to, what are we looking at? For the most part, we're looking at things that are moving meters and time scales that are seconds, so they're usually kind of bigger, if you will. And the gram is actually a small item. So a piece of gum is about a gram, a paper clip or a pen cap or a Skittle, all of those are about a gram. Well, I don't talk about a pen cap going down a road, I talk about a car. So why would I go with something that is that small to make a measurement of something that is that big, right? On the other hand, if I go to kilograms, I said a liter of water or your favorite beverage, a small laptop. Your introductory physics book, if you have a physical copy, is about a kilogram. Or a pineapple, right? The kilogram makes sense given the size of the objects that typically we're discussing when we're looking at the meter and the second as the base units for length and time. There is another base unit system. So we're working in something called MKS. So MKS, meter, kilogram, seconds. There is another base unit set, which is CGS, which is centimeters, grams, seconds. So they scaled the mass down and they scaled the length down to get another unit system that works well together, if you will. But we're going to be working here. And that concludes Unit 2, or Part 2.